Clean coal technologies represent a group of innovations designed to enhance the efficiency and environmental acceptability of coal preparation and use. With our nation's dependence on foreign oil, lawmakers, regulators, and industry leaders are beginning to focus on the use of clean coal technologies to ensure energy security and independence for our country. Coal is our most plentiful domestic resource. There is enough to last at least 275 years at our current rate of use. Based on a 60% recovery rate, we have 300 billion tons of recoverable reserves. It is cheap, plentiful, and secure. The U.S. is increasing its dependence on imported oil. Natural gas is becoming an international commodity subject to the same problems of supply as oil. The growth of the clean coal industry will bring a variety of opportunities to Kentucky. In addition to the economic and security benefits, clean coal technologies can ensure continued use of Kentucky's coal resources in an environmentally sound manner. This presentation will explore the processes and benefits of clean coal technologies. You may watch the entire presentation or click on one of these individual topics. Gasification is the cornerstone technology of clean coal processes. Gasification technologies are used in a variety of industries to manufacture a wide array of products. Gasification is the first step in the process of producing clean and efficient energy, fuels, and other valuable products. The chemical reaction in the coal produces a hydrogen and carbon monoxide-rich gas called synthesis gas. Synthesis gas can be used in electrical power generation, the production of transportation fuels and other chemicals, or through upgrading as a replacement for natural gas. Synthesis gas can also be used to produce ammonia, fertilizers, synthetic fuels, and waxes. Because gasification uses oxygen rather than air to produce synthesis gas, the resulting gas stream is smaller and is not diluted with nitrogen. Sulfur removal is an integral part of this process. With more carbon dioxide and no nitrogen or sulfur in the gas stream, cleanup methods are cheaper and more efficient than for traditional coal combustion methods. Natural gas is a fossil fuel composed primarily of methane. Natural gas is found in oil and gas fields, as well as coal beds. Natural gas is used to produce gasoline, diesel, hydrogen, and fertilizers. It can also be used to cook food, heat homes, and generate electrical power. In recent years, the price of natural gas in North America has increased due to a rising demand for electricity. This has been called the North American natural gas crisis. The solution to the natural gas crisis is to find alternatives to natural gas to accommodate the rise in demand. This domestic shortage in natural gas can be resolved by producing synthetic natural gas from coal. Synthetic natural gas, or SNG, can be produced so it is chemically identical to pipeline quality natural gas. This causes carbon monoxide to react with the hydrogen in the synthesis gas. The reaction produces synthetic natural gas. The synthetic natural gas is then cooled, dried, and compressed. Because SNG is chemically equivalent to natural gas and has an equivalent energy content, it can be transported through existing pipelines and tankers and used in the same applications as natural gas. During the process of manufacturing SNG, ammonia can be extracted and used to produce fertilizers, disinfectants, nitric acid, and universal gas odorants. Coal-to-liquids technology converts synthesis gas into hydrocarbons, which may be used to produce transportation fuel, such as super clean diesel and gasoline, as well as chemicals. South Africa has produced coal-derived fuels since 1955. Currently, 30% of South Africa's gasoline and diesel needs are produced from coal. Sasol, a South African company that specializes in synthetic fuel production, has plans to build plants in other countries around the world. Fischer-Tropsch synthesis can convert synthesis gas into a range of useful products, such as transportation fuels, synthetic waxes, alcohols, chemicals, and methane. The waxes are used in many applications, including adhesives, inks, textiles, and polishes. Because all sulfur is removed in the gasification process, the diesel is far cleaner than the Environmental Protection Agency's requirements. By using oxygen rather than air to gasify the coal, the gas stream is smaller and less diluted. With a more concentrated gas stream, cleanup is more efficient. The clean synthesis gas is used to produce clean-burning coal-to-liquid fuels. CTL diesel, for example, is sulfur-free. CTL fuels have a much higher cetane number than petroleum-derived fuels. A high cetane number means they burn more efficiently. Coal-to-liquid technology is helping the United States in its quest for energy security and independence. These technologies enable American companies to produce valuable products from Kentucky coal. CTL-produced synthetic waxes can be stored indefinitely and used at any time, providing an additional security benefit from this technology. Coal and other hydrocarbons have been gasified for the production of chemicals, fertilizers, and synthetic fuels for more than half a century. It is only in the last 20 years that coal gasification has been used to generate electricity using the integrated gasification combined cycle process. In a combined cycle power plant, 2 turbines are used to generate electricity. First, hot gas is used to power a gas turbine and produce electricity. Next, waste heat is recovered and used to boil water, producing steam for a steam turbine. This added step generates more electricity from each pound of coal, and does so more cleanly compared to traditional coal combustion because the gas stream is concentrated. The IGCC process produces electricity cleanly and efficiently. In a conventional power plant, emissions are removed at the end of the process. With IGCC technology, pollutants are removed from the synthesis gas before it is burned. Carbon dioxide is believed to be one of the leading causes of global warming. The gasification process allows carbon dioxide to be removed from the waste stream through carbon capture and utilization or sequestration technologies. Because of concentrated levels of carbon dioxide in the waste stream, gasification is more amenable to carbon capture and sequestration than the combustion exhaust known as flue gas from conventional coal combustion. Carbon capture and sequestration are in various stages of research and development. These technologies will one day help limit the impact of fossil fuel use on the environment. Carbon capture and sequestration, or CCS, involves separating, pressurizing, and storing carbon dioxide from fossil fuel use. The CCS method closest to implementation is a post-combustion capture, which can be applied to existing pulverized coal combustion power plants. After coal is burned to generate electricity, a chemical solvent is used to extract carbon dioxide from the flue gas. The cleaned flue gas can then be released into the atmosphere. The captured CO2 then may be pressurized and transported. As more clean coal technologies come online, these processes will become more efficient and economical. Carbon dioxide can be stored indefinitely in geological formations including deep saline aquifers and depleted oil and natural gas reservoirs. The U.S. Department of Energy's Regional Carbon Sequestration Partnership estimates that the U.S. has sufficient sequestration potential to hold all of its CO2 emissions for the next 1,000 years. Enhanced oil recovery is the clean coal industry's response to the growing market for captured carbon monoxide. Enhanced oil recovery is a technique that uses captured CO2 to increase the amount of oil that can be extracted from depleted oil fields. With enhanced oil recovery, captured CO2 is injected into depleted oil wells to force otherwise unrecoverable oil to the wellhead. Captured carbon dioxide may also be injected into unminable coal seams to displace methane, which can be recovered and marketed. Once all recoverable oil is extracted using CO2 enhanced oil recovery, the well is then sealed to ensure the safe and long-term containment of the injected CO2. For every ton of carbon dioxide stored, up to 4 barrels of oil can be recovered in oil fields. Petroleum companies are beginning to pursue CO2 enhanced oil recovery projects. The Dakota Gasification Company in North Dakota produces synthetic natural gas from coal and captures and pressurizes CO2 at its gasification plant. It then transports it via pipeline to the Weyburn oil field in Saskatchewan, where it is used in enhanced oil recovery. According to a 2006 report issued by the U.S. Department of Energy, Kentucky is an ideal state for enhanced oil recovery projects. The Kentucky Geological Survey has investigated the potential for oil recovery projects in the state and has identified several regions that would benefit from enhanced oil recovery. Kentucky ranks third nationally in coal production. The development of clean coal technologies will introduce new industries to the state and provide incentives for coal mining. With the growth of the clean coal industry, Kentucky will remain a key player in securing America's energy future. Clean coal technologies will ensure energy security and independence by utilizing our domestic energy supply. The Department of Defense is interested in using coal to liquid fuels for aircraft and military vehicles. CTL fuels produce more energy than traditional diesel and are less likely to freeze in extreme cold conditions. Using domestically produced CTL fuels will simplify battlefield refueling. It will make the country less vulnerable to supply chain disruptions caused by unpredictable events such as natural disasters and foreign wars. The military can avoid buying oil from unstable regimes by using American-produced CTL fuels. The development of clean coal technologies offers many economic advantages. A coal-to-liquids plant with an output of 10,000 barrels of transportation fuel per day, or the synthetic natural gas equivalent, could support up to 200 jobs on site, or around 2,000 related jobs throughout the region. The construction of the plant alone would provide approximately 1,100 temporary jobs, along with the addition of about 240 jobs at supporting coal mines. An IGCC plant can cost up to 20% more to build than a conventional plant, but the technology's efficiency would make it more economical to operate and would help companies eliminate costly future pollutant control add-ons. The environmentally friendly methods of clean coal technologies will help to lower Kentucky's emissions while maintaining our low-cost electric power. With gasification, impurities are removed from the coal-derived synthesis gas. Sulfur dioxide, mercury, and nitrogen oxides can be reduced or eliminated from the gas stream. Carbon dioxide is concentrated in the process and can be captured efficiently for use or sequestration. CTL fuels have a much higher cetane quality than standard petroleum. A higher cetane quality means CTL fuels burn more efficiently than petroleum-based fuels. Clean coal technologies are changing the energy industry and the world. By supporting the development of these technologies, Kentucky will ensure a brighter future for its economy, its environment, and its citizens. This presentation was made possible through funding by the Kentucky Governor's Office of Energy Policy. This educational tool supports the Kentucky Comprehensive Energy Strategy's 3 principles: to maintain Kentucky's low-cost energy, responsibly develop Kentucky's energy resources, and preserve the state's commitment to environmental quality.